Today we're going to talk about z-scores. Before jumping into questions and formulas for finding z-score, we want to know what is the role of z-score in statistics. Z-scores play a crucial role in statistics, especially when it comes to comparing different variables. Imagine you have two set of data with different scales. Comparing them directly can be misleading. For instance, suppose a student scores 35 on the ACT and 1500 on the SAT. It is hard to tell which exam they prefer better on because the score scales are entirely different. This is where z-scores comes into play. By converting these scores into z-scores, you can standardize the exam, allowing for a fair comparison between two exams. Essentially, z-scores help you understand how a particular score is related to the average performance in each dataset, making it possible to compare apples to apples, even when the original scales are completely different. In short, these scores are an essential tool for comparing data from different scales, ensuring that your comparisons are accurate and meaningful. So let's jump into how you could find these scores. So you can find these scores by using this formula. So this is a z-score that is equal to some value or given value. In our case, given value is 35. The student score on the ACT negative. You want to subtract the mean score of this exam from the value that you are given. In this case, our mean score is 25. Let me just write this formula in general. So you want to write the mean. All right, let me just clarify this. It mean to be mean. You want to divide this all difference by standard deviation of these scores. So this is basically this is the formula for finding z-scores, and let's apply this formula to our particular case. So we want to know in which exam this student performed better. So by looking at this data, it is too hard or too it's not legitimate to say that student scored better on SAT because it is far more better than mean score, or ACT because students score far more better than the mean score. But we want to make conclusion that is legitimate and can be sound more better. So what we want to do is we want to find these scores, and finding these scores allows us to compare these two different data sets even though their values are completely different and seems like not that good for comparison with between these data. So let me find the z-score of this student on ACT. So to find z-score, I basically use the formula that I've just written. So 35 negative 25 over 5 gives me the value of 10 over 5, or it's just 2, right? So this is a z-score for ACT exam. So I want to find the z-score of this student for the SAT exam now. The z-score for SAT, 1500 negative 1200 gives me the value of 300, all right, and divide this by 200 gives me the value of 1.5. This is the z-score for SAT exam that this student has taken. So now I have these two z-scores, and these z-scores are different, which tells me that the higher the z-score means, the better this student performance on exam, right? So which means this student did better on SAT. So that's the main conclusion that or comparison that you can make from this data that is given to you. So if we consider the next problem, we can actually see the basic imagery of what is z-score and how it can play a really crucial role when comparing two different data. So two populations of students were measured for their heights. The data for both populations are summarized in the table below. Question: calculate the z-score for the student's height in both populations. Which population has a student who is taller relative to the population's average height? So in order to know which student is taller, we need to find out the z-scores. But let's assume that we do not know what z-score is and what is the role of z-score for in statistics. Now, looking at this table, what I can see is population, the student in population B, student's height in population B is like 160, and seems like not that good for standard deviation makes you more and more uncomfortable for making any comparison, let alone like conclusion. That is why I'm going to use z-score safely. So z-score for the student in population A, what I'm going to do is just, I'm going to subtract the mean from the student's height in population A, and I'm going to get 165 over 10, which gives me the value of 5 over, 5 over 10, 5 over 10, or 1 over 2, all right? 1 over 2 is the score of the student's height in population A. So now I'm gonna go ahead and find the student's height in population B. To do so, I'm gonna do the thing that I've just done. So I'm gonna subtract 155 from 106, which gives me the value of 5, over standard deviation, and 8, which gives approximately with a value of zero point 0.6, right? 0.6, and this is the value of 1.5. What I'm seeing is now the student in population B, our question was which population has a student who is taller relative to the other population, relative to their population's average height. So the student in population B have taller height relative to their population's average height. So we can simple safely conclude that the student in population B has taller height relative to their population, their population's average. So that's why student B, the student in population B has taller height relative to their population's average height. So the question 3 is really interesting. So if you want, you can pause the video and feel free to use the knowledge that you've just learned now. So let's do this question. A study measures the income levels of two different groups. The income data is summarized in the table below. Find the z-scores for the income of the individual in both groups. Which group has the individual earning a higher income relative to the group's average income? So the z-score, our first question was finding the z-score. So I'm gonna find the z-score, and if I subtract 50,000 from 70,000, I'm gonna get the value of 20,000. All right, so 20,000 over 10,000 gives me the value of 10,000. Sorry, 1,000, 10,000, which gives me the value of just 2, right? Yeah, 2. Z-score for this group 1, and Z-score for the group A's person's income, I'm gonna get the value of 15,000 or 7.7 75, right? 7.5, which is the same as, so it's gonna be 15, and 15 over 70.5 gives me the value of basically 2, right? So now I can make some conclusion based on this z-scores now. So I have two exactly same z-scores here. And what does it mean? So this means that these two group, I mean, the which group has individual, these two groups income has exactly same relative to their average income, to the groups they are in, to the groups that they are in. So we can conclude that their average income is the same with each other. So there is no person whose income is larger or smaller than their group's average income.